Hello and welcome to this latest video in the OCR GCSE Computer Science series. In this video we're going to be taking a walking talking mock of the May 2022 paper for Unit 1 Computer Systems. Now, depending on when you're watching this video, you might struggle to find a copy of this paper. The paper isn't due to be publicly released until January 2024. So if you can't get access to this paper, you'll need to ask a teacher to download it for you, as any teacher who's part of a school that teaches any subject from OCR is able to access the password protected site that OCR run. So it'd be useful if you had a copy of the paper in front of you. As always, I will show you each page of the test paper and then I will go through a model answer. And those model answers are going to be the way that I think you can get the most marks, 80 out of 80 in this case, by writing as little as possible and focusing just on the really important key content. Before we start, there's a quick reminder of exactly what's included under Unit 1. So Unit 1 is made up of 6 key sections, and in any of the Unit 1 papers you could get questions from any of those key topics. So those are the areas you're going to be wanting to revise in the run-up to your real paper. So let's get started, and we've got a question to start with that is asking us to convert between megabytes, petabyte, kilobytes, bytes, gigabytes, and we're given some file sizes down the left hand side. Now this is one where you're going to need to know the calculation. We know that kilo means 1,000, and then every step up from that we just add another 3 zeros. So to convert from kilobytes to megabytes, for example, we're going to need to add another 3 zeros on. That's the answer you're going to want to be giving for question 1. So 2,000 bytes is 2 kilobytes. In the GCSE we always use 1,000 bytes to a kilobyte. It's actually 1,024, but you don't need to worry about that until A level. We've got 2,000 terabytes, and that is going to be equal to 2 petabytes, 16 bits, which is 2 bytes, and 4 nibbles. 4 nibbles is exactly the same, it's just another way of saying 16 bits. 4 marks available there. You get 1 mark per row, and it's just 1 tick per row. If you put more than 1 tick, you certainly can't get a mark. We then need to convert the number 221 into 8-bit binary. We're also asked to show our working, so we're getting a 2-mark question there. There are lots of different techniques that teachers will teach for binary. I always teach that you label the binary numbers across the top: 1, 2, 4, 8, 16, 32, 64, 128. And you'll notice that those numbers just double from right to left. All we've then got to do is work out which numbers need to be on, or have a 1 underneath them, to add up to 221. So in this case, I want to switch on 128, 64, 16, 8, 4 and 1. I know it's an odd number, 221, and if it's an odd number, I know the final bit will have to be on. Be careful with these sorts of questions. It's asked for an 8-bit binary, so even if the left-hand number was a 0, we'd still need to make sure we wrote that down to give our answer in 8 bits. You're getting a 2nd mark for showing your working, so that bit above the answer is quite important because that's where I did my workings out. I then need to convert the hexadecimal number 2F into denary. Now again, there are lots of different ways of undertaking a question like that. First of all, I need to look at 2 and I need to look at F as 2 distinct different numbers. So a 2 is equal to 2, and I need to make 2 in binary, but I'm giving the answer as a nibble, 0010. I'm then taking F, and I know that F is equal to 15 in hexadecimal, so I again work out that, and that is 1111. I'm then going to put both of those 2 numbers together, so I've got my answer now into binary. I'm then going to convert from binary into denary, and again I'm working out which of those numbers are switched on. I know that if I labelled them right to left, I've got 1, 2, 4, 8 and 32 switched on, and therefore the answer is 47. We're then asked to convert the binary number into hexadecimal. Again, I'm going to look at it as 2 separate nibbles. So I've got 1011 and then 4 zeros. Now 4 zeros should be easy. That's definitely going to equal 0. So I know it's something 0. I then need to convert my 1011 and I'd work out that, right, that is going to become 12, and I know that a 12 is equal to B. So my answer there is B0. Identify how many unique values can be represented by 4 bits. Well, it's 16. We can go from 0 to 15, so I've got 16 different bits that can be represented. I'm afraid that's one of those questions where you're just going to know the answer or not. And finally, I need to perform a binary shift of 3 places to the right on that binary number. In effect, I move all of the numbers to the right by 3 places, and I bin off any of the numbers that go off the right-hand side. So I've added 3 zeros to the left, moved everything across, and that in effect is undertaking division of the original binary number. So a right shift to undertake division is going to give that as your answer. We're then being asked around the von Neumann architecture, and it's asking me to complete the table by writing the missing definition below, or the name where the name is blank. And I'm looking for the different CPU components or registers. Now again, this I'm afraid is a question where you need to know those definitions and you need to know those labels, and the correct answers are shown there. We've got the program counter, the memory address register, and the arithmetic and logic unit down the left-hand side. The control unit, you need to have something there around controlling the rest of the CPU, organizing or giving the instructions to the rest of the CPU. It also decodes instructions. You only actually need one of those 2 points there, the control element or the decoding instructions. Either of those would get you the mark. Again, you could have a look through the mark scheme because there are other answers acceptable, but that for me is the easiest way of answering that one. The left-hand answers are set. So it is program counter, memory address register, and then arithmetic and logic unit, and those are the only ones that will get you the mark. So we've then moved on to a section of the paper around networks, and particularly local area networks in the first part of the question. I'm being asked to explain why the number of devices using the network at the same time can affect performance. Now the pitfall here is that most students don't get 3 marks. You might get 1 or 2 marks, but getting 3 marks is quite difficult. You need to make 3 distinct points. Now whenever I answer a question like that, I bullet point my answers. Don't do that in the essay question, but for every other part of the paper, bullet pointing shows that you are making those 3 separate and distinct points. The bandwidth is split between more devices. This means less bandwidth is available for each device. Those are the 2 you've probably have got. You then need to think around, right, what will my third one be? And this one is a little bit more difficult. It's around the router having to handle more requests, and therefore there might be a delay within some of those requests. By using those sort of bullet points, I've made it really, really clear to the examiner that I have made 3 separate points. So I really would encourage you, when you get those 3 or 4 mark questions, to do that, and you'll see throughout this paper that I will do the same. I'm asked then to identify one other factor that can affect network performance. There's quite a lot of available answers here. Considering we've already mentioned bandwidth, I'm giving that as my answer. Interference is another popular answer there. We've then got a really nice fill in the gap question. So we've got 7 marks available here, and we've got some words that we can squeeze into those separate gaps. A website is hosted on something, and then again, gaps going on down through that. This is a question where there are only one set of right answers, and those are shown on your screen. Web servers hold the websites. The computers that connect are called clients. The user enters a uniform resource locator. The web browser sends the request to a domain name server. It's then asking at the bottom around this idea of IP addresses. IP addresses are between 0 and 255, and they're separated by full stops. So that is the only set of answers that you can have there for the second part of question 3. We're staying now on the networking part of Unit 1, but we're looking around standards, and then later on in this page, routers. This is a really tough question. Explain why Ethernet is a standard, and there are a limited number of points here that you can really make. Ethernet is a standard because it's used by nearly all manufacturers, so it is an agreed standard. It's an agreed connection type. It needs to be the same to allow compatibility, so it needs to be a standard so that I can plug my Dell laptop into my HP router. So it's a standard because it's that defined connection method. Okay, so you need to be thinking about that idea of a standard being agreed across lots of companies and it always then being the same. Another tough question around routers in that you're being asked to identify 3 tasks that are carried out by a router. You can probably get 1 or 2, but again, getting all 3 is a little bit tougher. Routers receive packets of data, they maintain a routing table of connected devices, and then they forward packets onto the correct destination. Now again, there are a couple of other answers available for that one, but that's going to be your best set of answers. Receive data, keep an address list of exactly what devices are connected, and then forward packets on to the correct destination. A library does not use encryption when data is transmitted through the network. Give 2 reasons why the library should use encryption. You cannot say here it's to stop data being stolen. The data can be stolen just as easily, but it can't be understood if it is stolen. Okay, so that first point, you've got to have that word understood. The data cannot be understood if it's stolen or intercepted or found by a hacker or something like that. Your second point should probably be around something like to meet legislation. So I've referenced there the GDPR, which is the European General Data Protection Register, and then the Data Protection Act, which was the UK version we had before that. Again, a couple of other options there, but you must identify that encryption doesn't stop things being stolen, it just stops them being understood if they are stolen. We've then got a question around protocols, and it's asked us to identify protocols that perform sending an email and then accessing a website securely. SMTP is the sending email. Just remember that one of them begins with S, and the SMTP means send. And then the same with the website security one. It's HTTPS at the end, and the S is our secure method of connecting to websites. We've then got the long essay answer question. This is often at the end of the paper, but in a couple of the more recent years, they've put the essay in the middle of the paper. Now you need to decide whether you want to attempt that there and then, but if you don't, you need to make sure you leave yourself 20 minutes at the end to go back and answer this question. Okay, it's really, really key. It's an 8-mark question. You need to be getting 5, 6, 7 marks for it. It's asking around artificial intelligence and monitoring posts on websites. It's asking us to discuss the positives and negatives of using AI. Now, I'm not going to read my answer word for word, but what I've done very clearly here is split my answer into 3 paragraphs. It says you might want to discuss legal, ethical, and privacy. Therefore, I've got a paragraph about legal issues where I've made 3 definitive points. I've got a paragraph about ethical where I've made another 3 points, and finally privacy where I've tried to do the same. I have put a little conclusion at the end. There are spag marks available within this question, so it's something like that you're going to need to form. Don't feel like you need to fill up both sides. If your handwriting is not massive, you can definitely get away with filling up just one of the 2 pages that are available for this question. I'd strongly suggest that you pause the video at this point and have a read through my answer. Like I say, I won't read it word for word, but some of the points there are quite complex and difficult, and it's important you understand exactly the sorts of points that will get you a mark. So pause the video at this point. So the next set of questions look at security and how we can keep data secure. The first one says identify 2 methods of physical security that a company could use to protect their computer systems. There is a really key word in that question, which is physical security. Passwords? Nope, not going to get you the mark. Antivirus? Definitely not. They're asking for physical things we can do to keep this company's computers and data secure. And there are some really, really obvious answers that students have seemed to miss from the round of exam papers of this exam that I have marked. Lock doors, biometric locks, anything to do with locks, padlocks, any of those things. but also things like security guards and CCTV or alarm systems as well will get you the marks. But it's got to be physical security, so make sure you are reading that question really, really fully. We're then asked to identify and describe 2 software-based methods. Now, this is where we could look at things like encryption or antivirus. It's a 6-mark question, so we're getting 2 marks for naming the method and then 2 marks for each of the descriptions. So I've gone for a firewall, and a firewall scans incoming and outgoing traffic. That's my first mark, and then blocks unauthorized or suspicious traffic. So I've got 3 marks there, 1 for firewall, 1 for the idea that it scans traffic, and another mark for the idea it then blocks malicious or suspicious traffic. Same for antivirus. It scans files to identify viruses and then deletes files that look suspicious. Too many students on this question get 4 out of 6. They say firewall, they say it scans traffic, but that's not enough to get you the 3 marks that you need. Make sure that when you get questions like this and you do know the answer, you really maximize the number of marks you get on each question. We've got another nice tick box answer here. Tick 1 box in each row to identify the legislation that would cover each of the given events. We've got then some events down the left-hand side and some legislation. We've got the Data Protection Act, Computer Misuse Act, and the Copyright Designs and Patents Act. Again, I'm afraid there are only 1 set of answers for this one. So the first 2 are the Data Protection Act. The third is the Copyright Designs and Patents Act. And then we've got 2 that are the Computer Misuse Act. So think about that question. You know, one is called the Computer Misuse Act. Which of those sound like misusing a computer? Which of them sound like they're to do with data and protecting data? This is a question you could work out even if you've never had a computer science lesson before. We're then looking at binary again, so we're looking at how we can convert binary, looking at sound waves, but also then how that impacts when we increase things like the duration and the sample rate. The first question asks us to describe how an analog sound wave is converted into digital form. Now again, I need to make 3 marks. Top tip, use those bullet points. You'll see here I've clearly made and I've clearly showed the examiner my 3 points that I am going to make. The height of the sound wave is measured, first mark, at set intervals called samples, second mark. Each sample is then converted to binary. You don't need to overcomplicate that answer. You don't need to start talking about bit depth or how we move it into binary. You just need to make those 3 key points, which I've done there very clearly with my bullet pointed answers. It then says tick 1 or more boxes. So again, really key, we read the question. 1 or more is highlighted in bold to identify the effect that each change will have on the sound file. So the file size increases when we increase our duration, the accuracy decreases with the sample rate, and then the bit depth is going to be 2 of those things as well. Okay, so in each case we're thinking about accuracy, but also the file size. So again, you've got a mark per row, but you only get the mark for the bottom 2 if you've got that row correct. A little question then around character sets, looking at how we convert from binary numbers into characters and how those characters might be represented with the ASCII denary codes. We've been told that M, N, O, P, Q are equal to 77, 8, 9, 80 and 81. You can see there that that's in alphabetical order. It then asks you what character would be 84. So this one really is as simple as just carrying on down the alphabet until we reach the letter T. So 84 would represent T in this example. We're asked then to identify another character set. There are only 2 character sets in the GCSE, ASCII and Unicode. It's asking for another, so Unicode, because we were given ASCII in the previous question. So Unicode is the only answer you can get there. A student then takes a photograph of their science experiment. The image file includes metadata, include 3 pieces of metadata. This is a question that's really easy to overcomplicate. You could start talking about geotagging and all of that sort of stuff. Let's keep it simple. Height, width, color depth. We can't possibly recreate the image without those 3 things. So don't overcomplicate that answer. Keep that nice and simple. The student compresses all of their documents before emailing them to the teacher. We want to give 2 benefits of compressing the data before it's emailed. It's going to take up less storage space. So if our email account has got storage linked to it, we might only have a certain amount of storage space, or the storage of our computer. It's also then going to take less time to send and less time to download. You could just put those 2 things. Less time to upload, less time to download could be your 2 answers. We're then asked to explain why lossy compression may not be appropriate to compress all of the students' files. Data is lost with lossy compression. It's lost forever, and we might not want that to happen. The teacher might need the full quality of the work to mark. So if they were marking a picture, we might need them to mark the very top quality, top version of our work. There's also the idea that we can't compress Word documents because we can't just get rid of every other word, because else our work might not make sense. So there's another set of answers there you could put around not being able to encrypt text files particularly easily. We're then looking at a smart television, and this is another set of questions that weren't answered particularly well in the set of papers that I have marked for this May 2022 paper so far. Firstly, we're asked to state the difference between RAM and ROM. That comes up nearly every year. The answer is always going to be that RAM is volatile, ROM is not volatile. Again, we're getting 1 mark for saying that difference. We're then asked to give 2 examples of things that are stored in RAM. RAM is always to do with the currently running things, the currently running applications, the currently running data, the currently running instructions. So it's all to do with that idea of things that are currently happening. So I've gone for the apps that are currently running and the film that's currently being watched. So if I've got my film paused, that would be in the RAM and exactly where it's paused, but only the one that's currently being watched. Okay, so on a posh Sky Q box, you can pause lots of different films. It's only the current one in the RAM. Just remember that word. Anytime RAM comes up, it's the currently used apps, currently used instructions, or data. State, using an example, why the smart television needs secondary storage. So ROM is fixed. It's programmed in the factory. RAM stores all of our currently running instructions, but we haven't got anywhere yet where we can store things in the long term. To store data once the power is switched off, such as purchased apps or files. It says using an example. So you get 1 mark for why we need it, and then a 2nd mark for our example. Really important that when you get questions like that where you do know the answer, you maximize your marks. You're not getting 1 out of 2, because that's going to limit you to a grade 5 if you do that on every question, but you're nailing 2 marks out of 2 and getting then on track for that grade 9. Final question says, identify 1 appropriate type of secondary storage. There are only 3 types: optical, magnetic, and solid state. You can't put hard drive. You can't put CD, because the question has very specifically asked you for the type. I have said that solid state storage is going to be the one that I think is most appropriate, either in the form of a USB stick, but I can't get a mark for USB stick, or a solid state drive, which is a type of solid state storage. Why do I think that? And I need to make 3 points here. I've gone for 4 to be belt and braces. It's very, very fast. Solid state is the fastest type of storage. It's got a large capacity. It's not the biggest, but it is still large. It's silent. There are no moving parts in a solid state drive, so whereas a CD or a magnetic disk would make noise, a solid state drive will not. And it's very robust. As long as you're not dropping the TV or chucking the TV on the floor, it should last a very long time. So that is how I believe you should get 80 marks out of 80 on the Unit 1 paper from May 2022. As always, think about bullet pointing those answers. Think about getting the absolute key answers in there and not blabbering on around sort of random bits that don't really relate to the question. At this point, I'd go through and add up how many marks you think you honestly would have got without any assistance. Maybe then use a purple pen to go through and correct any areas you could improve on. As always, there's lots of videos on the channel around things like binary numbers, audio files, and all of those topics we've covered. So if you have got a particular area of need there, do go and revise those in a little bit more depth, either through this channel or through another one online. As always, if you have any questions, please post those into the comments section below or onto Google Classroom. Thank you very much for watching.